Welcome to lesson 14. So we're going to talk about the general rules for probability. So we're going to focus on Venn diagrams. We're going to talk some terms and mention the addition rule. Okay, so here's this example we're going to use throughout this lesson. We are going to look at a club of bio majors, and we have a handful of them are pre-med. So if you look at these 5 right here, they are pre-med. We put the letter M on their heads to denote this. Some of them are, this is a capital I. They're international students. They have the letter I on their torso. These are really just very basic labeling here. And so we have these steps. We're going to go ahead. We're going to group them by events M and I. You might notice that I put the pre-med students next to each other. I also put the international students next to each other. It's going to make things easier. Thankfully, I pretty much always have to have this, or I forget. I made there a lot more room on the next slide. So the first step is always going to be to draw a rectangle around them. I don't know why it's always a rectangle whenever we draw it, but you have to have this rectangle. And the idea is if you add all the probabilities inside of it, it adds to 1 or 100%. So I have this 1. I'm going to draw, this is an S for the sample space. So everything in here is 100% of the possibilities. I have my pre-med students here. It looks like there are 5 of them out of 10 students. So 0.5 or 50% chance that if I randomly select a student, they'll be pre-med. If I decide, hey, how many of them are international? It looks like 4 of them are international students out of 10. So 0.4. So 40% of this sample of students are international. So if I went ahead and have both. So I'm going to label any students in this circle are I for international. Any students in this circle are M for pre-med. And you note there are some students that aren't either, and that's okay. In fact, it's kind of weird if there aren't any that are in either group. So then, if I want to know the probability that I randomly select a student and they're international and pre-med, it's asking me about this wedge here. That's what it wants. So it looks like I have 2 students that are both. So 2 out of 10 is equal to 0.2. So there's a 20% chance if I were selecting at random that I might select a student that is both pre-med and international. And then throw back to our complement notation. This one's asking, what is the probability I randomly select a student, they are not an international student, and they're not a pre-med student. So I need to find the students that aren't international and they aren't pre-med. So looks like, honestly, I'm looking at these 3 people. So there are 3 people that aren't international and they aren't pre-med out of 10. So it's going to be 0.3. So as far as labeling in here, if I have 2/10 in this wedge right here, that's equal to 0.2. Same here, if I look in this like half moon shape, I have 2 out of 10, which is 0.2. If I look in this wedge right here, I have 3 out of 10, which is 0.3. And then if I look everywhere outside, I have 3 people out of 10 are neither international or pre-med, 0.3. So when you're done labeling and your Venn diagram, if you add that 0.3 plus 0.3 plus 0.2 plus 0.2, so that you add all the probabilities in here, it should add to 1. If it adds to anything else, something went sideways, go back and check. When you have your Venn diagram all completely labeled correctly, all of the probabilities added together should add 1. Also, things to note, if I just look at international students, I basically add this wedge and this wedge together, so 0.2 plus 0.2, that's how I get 0.4. If I look at just pre-med, I combine those wedges, so the 2/10 plus 3/10, that's 5/10, 0.5. That's where I get that. It's the Venn diagram. The first place we start is drawing a rectangle. The circles come afterwards. So the sample space, I have a tendency to write it out here. It doesn't matter as long as it's, labeled somewhere. So we'll have one event that we're interested in. This is the event A. The area it takes is the probability of event A happening. Then we'll have a second one. Trust me, Venn diagrams can get complicated. They don't have to have just 2 circles. We're going to stick to just 2. So event B. And this shared spot is the probability A and B both happen. And then you don't want to forget the not A and not B. So if you add the probability of this wedge is only A happening, so only A and not B. A and B both happening, just B happening and not A, and the probability of not A and not B, they should always add to 1. Always. So if you add these 4 together, they should always add to 1. So some definitions here. We talked about an event being a subset of all the possible outcomes. It could be pretty much a subset of all of them, but most of the time it's going to be a smaller subset of our sample space. Then we have the complement of an event A. So if A is rolling an odd number, the complement of A is rolling an even number on a dice. So we're going to use A with a C. Some other folks might use A prime. That's okay. Just know that if you look online, you might see that. I'm going to stick to A with a C. So the idea is if you added the probability of A happening and the probability of B, A complement happening, that's everything. So then intersection. For me, it helps me to think of, one, if you're into, I've been doing research on intersectionality lately, but the intersection, if you're looking at, you're at a road, the intersection is where 2 roads meet, right? The intersection doesn't belong to just one road or the other. You are simultaneously on both roads. The intersection is where they share space. So whenever we say A and B happening, it has to be this place where they overlap. If they don't have any common outcomes, we say they're disjoint. What that means is if A and B are disjoint, only one can happen at a time. They cannot both happen at the same time. So for example, maybe I'm doing a raffle and I draw a ticket and it can only have one winner. The event where I win the raffle and the event where my friend wins the raffle, those are disjoint because if they draw one ticket, we can't both win. If I win, then you know that my friend didn't, and vice versa. So the idea of disjoint, you could draw it as having no overlap. There's no overlap at all. And then the union of two events, so A or B. So it's the idea that A can happen or B can happen or both. So A, B, or both A, B, and B. A and B. So intersection, it has to be both of them. Union, either one or both. So we're going to have an example here. We're looking at a Pew Research study here that said 77% of adults in the U.S. have a smartphone. I'm not sure how old this is. I almost feel like that's higher. 65% access the internet at home with broadband, and 52% access with both. So our first step, draw the Venn diagram. Then we're going to go ahead and calculate some probabilities. Okay, so the first place I want to start, and I'm sorry about making this S. It was worse when it was P for phone. There are certain letters that aren't great to use in probability. S is kind of one of them. So I'm going to go ahead. The first thing I did, so my sample space, that means that everything inside has to add to 1 when I'm done. So this is going to be S for smartphone for me. I know, try and make it look different from this one. Ooh, I'm not good enough to do it that way. I'm going to have more overlap. So B for broadband. So there's a start. The first place you should always start once you have your rectangle drawn and your circles and labeled is this overlap. It is always the first place you start labeling anything in here. So I want to find, 52% have both. So 52%, because it's going to go here. Then I'm going to look at smartphones, because I think they came in here first. So 77%. So that means when I look at this whole circle, I want to see 77% in all of its wedges. So problem, look here. If I go ahead and write 0.77, I know right away when I add these probabilities it's going to go over 1. So since I want this whole thing to add to 0.77, this half moon wedge right here, it's going to be 0.77 minus that 0.52. So equals to 0.25. So it's saying 25% of folks, of adults in the U.S. have a smartphone only. Like they have a smartphone, but they don't have broadband. And then looking at broadband, so 65% in this entire thing. But like I said, you don't want to just have 65 here. You even just add those two, you know it'll go over 1. So minus 0.52. So I'll get 0.13. So 13% of U.S. adults have broadband, but they don't have a smartphone. So I will get to, let me see. We've drawn the Venn diagram. We are missing something out here, right? Because there are some U.S. adults that don't have a smartphone and they don't have broadband. But let's, real quick, go through some of these. This might help. So I'm actually going to wedge this one in here. It really should go in between. So the probability they have a smartphone, it's just going to be this 0.77. But you can absolutely focus on here. You can add that 0.25 and 0.52. That's one of your ways of checking that you did math right here. So you should get back to that 77%. Going to be really similar. They already gave us the probability of randomly selecting an adult that has broadband. It's going to be that 65%. But if I wanted to just focus on here, I can add the wedges up. Obviously, this is not built to scale or drawn to scale. I am horrible at drawing these to scale. I'm not that good at it at all. So you add those wedges back together and you get back to here. That looks good. So the probability of both, they gave us that right there. That's just that 0.52. So then I'm going to say, okay, well, the probability that I randomly select somebody and they have a smartphone or they have broadband or they have both. So they have at least one of them. I can add all parts of these wedges here together. So 0.25 plus 0.52 plus 0.13. And I believe this should add to 0.90. So what this means, and I have to constantly step back and ask myself, did I answer the question? If I were to randomly select a U.S. adult according to this survey, 90% of them have a smartphone and or broadband. They have at least one of those. So now I'm going to go back to this question. So if 90% have at least one of them, what's the probability you randomly select someone they don't? So it's going to be 1 minus this 0.90. I can write. So that's going to be 0.10. So 10% of the U.S. adults do not have a smartphone or broadband. So then when you go to check, you add 0.25 plus 0.52 plus 0.13 plus 0.10. When you add those together, you should get 1. And now this Venn diagram is done. But it was really, really important that you have that probability, and this is the one that people tend to forget. They tend to forget this probability. They label in here, here, and here, and they forget to label here. So just be thorough. Know that anytime you're doing a Venn diagram and it has 2 circles, there should be 4 different probabilities on it. So now we're going to talk about the addition rule, which is super handy. So anytime that I want to know the probability A or B happens, so at least one of them happens. So I will have the probability A happens plus the probability B happens, but I just counted the overlap twice. So now I have to subtract that overlap 1 time. So the rule itself is the probability A or B happens, so at least one, so A happens, B happens, or both happen. It's the probability A plus the probability B minus the probability of both of them happening. Because we accidentally just added it, the probability they both happen twice in there. If A and B are disjoint, you can say, we know that there's no overlap. So this part right here goes away, it becomes 0. Be careful. I would recommend just always using this one here. And if the probability A and B is 0, it goes away. Because this is such a specific subset of the time that it's equal to probability A plus probability B. This is only true if A and B have no overlap. They never happen at the same time. So using the addition rule. So we went ahead and we solved this without an addition rule, but we are going to go ahead. So it's the same problem as before, still that Pew Research. They're looking at smartphone and broadband. So I'm going to go ahead and relabel here. 0.25, 0.13. This was 0.10, right? So now that I have the addition rule, so remember last time what we did. Last time we said probability that S or B happened. We went ahead and we added 0.25. So we said, hey, I want this. So you count those 3 wedges. You went 0.25 plus 0.52 plus 0.13, and we got that 0.90. And that works. But now we're going to use addition rule. So that is probability S or B. And this one's handy because if you have all the probabilities labeled correctly somewhere, you don't necessarily have to draw out the whole Venn diagram. I personally am very visual, so I like the Venn diagram, but you know, everyone has different preferences here. So it's going to be the probability they have a smartphone plus the probability they have broadband minus the probability of both. I always feel like this looks like the word sand. I try to make and look smaller. Okay, so the probability of smartphone, that was just that 0.77, plus the probability of broadband, that 0.65, minus 0.52. So go ahead and add here 0.77 plus 0.65. We're going to get 1.42 minus 0.52. And I hope it doesn't surprise anyone. You get 0.90. Your answers absolutely should match. So this first one really depends on you having your Venn diagram handy and everything labeled correctly. This second one is less dependent on that. As long as you have the probabilities, you're okay. But if you've drawn a Venn diagram and you have the wrong probabilities in there, you're going to, if you use this first way, it's going to go sideways every time. But no, this is a great way to check yourself. If you do it both ways and you get the same answer both ways, that's good. So now, Buddy Kai, they're about to graduate with an industrial engineering degree. So they go ahead, they interview at 2 different companies. And I don't know where these probabilities would come from. Their probability of getting an offer from company 1, so C1, is 0.8. And the probability of getting an offer from company 2 is 0.6. They think the chance they'll get an offer from both is 0.5. Once again, I have no idea where they're getting those numbers. I don't think people get offered jobs at random most of the time. So which of the following is correct? So here, take a guess, and then we will, I'll give y'all insight on the answer there. Okay, so you might have noticed that I mentioned that there should be 4 probabilities. We have a probability missing outside of the circles on both of them. However, we can go ahead and rule out one of these actually pretty quickly. The fastest way to rule out a Venn diagram is if the probabilities add to over 1, that's not correct. It's never correct. So if you look here at the first one, 0.8 plus 0.5, uh-oh, I've gone over 1. That's 1.3 plus 0.6, it can't be. So 0.8 plus 0.5 plus 0.6, that's greater than 1. So it can't be diagram 1. So diagram 2, so I have 0.3 plus 0.5 plus 0.1. If I add that together, it's 0.9. That is less than 1, so I didn't go over. So now I actually have to double check. So if I have, this is C1, and I take this entire circle, if I add all of its wedges together, 0.3 plus 0.5, that's 0.8. So that checks out. And then similarly, if I go to company 2, and I add its wedges together, I get 0.5 plus 0.1. That'll add to 0.6, so that checks out. 0.5 is in the middle. And the thing that's missing here, so 0.3 plus 0.5 plus 0.1. And we are jumping ahead. It's going to ask us in a couple slides about this. We'll get 0.9. So if there's a 90% probability that at least one of the companies are going to give them a job offer. So 90%, at least one does. That means 0.10 or 10% of the time, no companies offer a job. So now if I add these four numbers, I should get 1. So diagram 2, that's the way to go here. So still hanging out with Kai. What is the probability they get an offer from at least one of the jobs? So I can add all the parts in the wedges, that's one way. 0.3 plus 0.5 plus 0.1. And that's going to be 0.9. The second way, using addition rule, so probability that at least one, so C1 or C2. So it'll be the probability C1 offers it, plus the probability C2 offers it, minus the probability of both. And I'm running out of space here. So that's the probability company 1, that was 0.8, plus the probability company 2 is 0.6, minus the probability of both is 0.5. So I'll get 1.4 minus 0.5, 0.9. So either way, they should take me to the same spot. Probability he gets an offer from at least one of the two is 90%. So then one more. What is the probability they get 0 offers? So just a reminder here, so the probability C1 or C2 that we just calculated was 0.9. I like to put a 0 so I know it's 90%. So this is at least one job, or at least one offer. So the probability they get 0 offers, so this is the probability that company 1 says nope, and company 2 says no thanks. So I could rewrite this is 1 minus the probability that at least one offer. Which we just calculated, right? We know the probability at least one offer. So 1 minus 0.9, I'm going to get 0.1. I like to add the 0 so I know it's a 10%. So if I go ahead, that goes here, because if they didn't get an offer from either one, that doesn't go in either of the circles. So 0.3 plus 0.5 plus 0.1 plus 0.1, that's going to equal 1. And that's our way of checking. It should add to 1. If it adds to anything else, go back and check something went sideways. So there are a couple more examples in the Your Turn slides at the end. Strongly recommend giving those a look. And we will see you in Lesson 15.